Hello, chemistry students. Today we're going to be taking a look at building your own vehicle. Now you can build a rocket, you can build a boat, or you can build a car. Any of those things are permissible, but I do need you to make a video of how well it works. Now, building any of these things, it doesn't really matter which one you build. I'd like you to try and find a video on it, take a look at it, see what they do. But remember that these people are not worried about the science. They're just trying to get it to go into the air or run around the ground or shoot down the water. I want you to worry about the science part of it. So since the first thing we have to worry about in the science part is the fuel. As we look at the fuel, we know that we're going to be using our vinegar and our baking soda. Now, when we make vinegar and baking soda, we're going to get water. Now, by the way, in the question I asked you, if you were in a plane and it crashed on an island, the only things you had were baking soda and vinegar, and why would you care? Well, if you're going to get water as one of the reactions, that's something you could actually drink. So if there was no water on your island, if you knew the proper combination to get a complete reaction, which means that there's no excess, you would end up with pure water. And if you had pure water, you could drink it. Save your life. Maybe. Now, the water part of this reaction isn't really going to be important to us. What is going to be important is the second thing that we're getting, which is CO2. Now, when you made your acid last week and you took that white powder and you cleaned the windows or the lights on your car, I hope that that worked for you. I haven't seen those yet, and I'm looking forward to it. But the one thing that we all need for this is the CO2. And the more CO2 we create, the better our reaction's going to be. There are some problems in creating this. And the first one is going to be, of course, what kind of a vessel are you going to use? So let's say that you're using this and you're turning it into a rocket, which is very typical in all the videos you're going to watch. The question is, how do you get your fuel in here and build up enough CO2 that you can launch it into the air? Now, for some of you who want to make a boat, perhaps you'll use something like this. Now, this is a Powerade bottle, and if you'll notice when I squeeze it, almost nothing happens. This is a very solid construction. Remember, when we're putting vinegar and baking soda inside this, it's going to create CO2. And if you watch the video last week about what you weren't supposed to do, and you had that kid shaking it beside his head with no glasses on, well, of course, the biggest thing he had to do was you do not want your bottle to explode. You'll notice that this one has a cap, a heavy cap, which takes a number of turns to screw it down. I have here another plastic bottle. I like this stuff, it's really good. Sorry, that was a commercial break, hoping to get an advertisement. No. Now, if you notice this, you'll see that this bottle collapses super easy, which means that the gas inside can expand it super easy. And the little plastic cap on top just barely goes on. So if you build up too much pressure, it can blow your cap off, or it can blow up your bottle. So you have to be careful about the vessel you're using. Okay, now once you decide which of these three vessels you're going to use, all right, how much vinegar and baking soda? You don't want to waste it. Now, alchemy would just waste it. They would just throw it in. You guys used the math that we have done over the last 3 weeks. You should be able to figure out how to make a complete reaction so that if you say, I have started with, and I use my graduated cylinder to measure liquids, and I decide that I'm going to use 50 milliliters of vinegar. The question would then be, how much baking soda do I need to get a complete reaction? Which I'm going to do on my three beam balance in grams. So I have to be able to convert between grams and milliliters, and obviously the conversion factor for that is going to be moles. Hopefully we've learned that. And I gotta be honest, being out of school, that's the biggest thing I miss, is we would have spent days in class doing those calculations and practicing those, so I knew that you guys had it. Most of you have not really showed me that you have that down yet. But for this, yes, you can do the alchemy. You can just keep adding a little bit more measurement till it's all used up and we don't have any excess of baking soda or vinegar. And then you say, that's what I'm going to use. It's not really what we're supposed to be doing here, but hey, you're gonna build a boat, so I'll take what I can get. Now, once you decide on that, here's the second part of it. So let's say in my boat, I were to put my 50 milliliters. How do I get the baking soda into it so that I have fuel? And you go, well, Mr. Bartlett, as soon as you put it in, you start getting the fuel. Not true. Well, true, I get a fuel, but as you saw on the scale and the one question I asked, if you violated the law of conservation of matter, when you put it in a beaker, it just bubbles away into the air. If I put it in my bottle and I don't have my cap on, it just bubbles away into the air, and by the time I get my cap on, there's no fuel left. So I have to find a way to get my vinegar and my baking soda into the bottle so that when I have a nozzle, it will shoot my boat down the track. Now, engineering that is really, really the hard part. And so trying to figure out how to create a mixture of my fuel at the time I want to create the mixture for my fuel so that I actually can use it in a correct way, that's really the hard part. Okay, one of the videos I've been watching this week also asks you to create a nozzle. Now, there are lots and lots of ways to create a nozzle. The easiest one is just to poke a hole in the cap. But if the hole's too big, it's like not having a cap on at all, and all of the fuel runs out, and there's not enough pressure to push your boat down the track. If the hole is too small, then it just kind of sits there and sputters and doesn't do anything. So you have to find the right size hole. For those of you who are thinking of going into aeronautic engineering, nozzle and thrust velocities are one of the key things that you're going to spend an entire year of school working on. At NASA, that is the single biggest problem. How do they get all of that energy to come out the right size nozzle? If it's too big, you don't get enough thrust to get into orbit. If it's too small, the rocket explodes and people die. This is really technical work, and it's one of the key elements for all of you who are thinking of engineering. Okay, so I've got to figure out the correct nozzle size. I've got to figure out the correct amount of fuel, how to blend my fuel, and then lastly, this doesn't look much like a rocket. How am I going to design this so that the air as it's shooting up isn't hitting this and keeping it from going as high and as fast as it should? Or if this is my boat and this is the front of the boat and this is where the gas comes out, well, how do I get this to go through the water without the water hitting it and causing it to take a nosedive or shoot up in the air and take off on me? Engineering the construction or the size of your vehicle is very important. Think about your cars. We build cars so that the wind passes over our car, pushes it down on the road, and actually makes it streamlined and a much smoother ride. Unlike the old Model Ts, where the wind actually picked those cars up as they were riding along. Not a good thing. So, we engineered the style of our boat. We engineer the nozzle on our boat. We engineer how the fuel mixes together, and we use chemistry to decide how much of each component of the fuel we're going to use. Chemistry and engineering working together. That's what we're doing this week, and I hope that you have a great time with this activity. Bye now.